The purpose of this video is for you to learn about the use of the final and static keywords in Java. Now, final comes up in 3 different contexts in Java, but today we're only going to look at one of them. The other 2 involve inheritance. Finality is a property of variables. Variables can be marked final, and that means that that variable, once marked final, cannot be reassigned. So let's go ahead and create a final variable. So you just say final. And now, variables that are local to a method can be final, or a state variable can be final as well. And that, in fact, is a useful way of enforcing immutability. So we're going to mark x final, and we're going to type x++. And we're going to compile this thing. And crash and burn cannot assign a variable to the final value to the final variable x. Okay, so this is illegal. Is a no-no. Cannot be reassigned. Okay, so we now have that. Now, let's try it for a variable of object type. Final string animal is equal to cat. Okay, and now I'm going to say animal equals dog. Okay, let's go ahead and compile this again. And you will see, once again, crash, burn. We're not allowed to reassign that variable. Yep. However, we're going to do one other thing that's a little subtler. Okay? Let's import our good old friend array list. And I'm going to come down here and I'm going to make an array list of strings. Okay, and I'll call it foo is new array list. And I'm going to say foo.add of new item number 1. Here, while we're at it, let's add new item number 2. Now let's compile this. Ooh. Notice something here. A final variable is pointing at a mutable object. Okay, pointing at a mutable object can change that object's state. Here's something to know about finality. Objects have no idea if the variables pointing at them are final. In other words, finality is a property of variables, not a property of objects. Immutability is a property of objects. Finality is a property of variables. Now, one other thing I should mention is something called constness. Constness means cannot be changed. And here is the rule for constness. Here are the essential ingredients. You need to have a final variable and either a primitive type or Okay? Notice that when I declared the primitive x to be 5, because I cannot reassign it, x can never point at any other value. So x is fixed and concrete. There is constness here. The same thing is true for strings, because a string is immutable and the variable here is final. Animal is married to cat for its entire lifetime. Now here, in the third case, if you have a mutable object and you have a final, oops, I didn't say final here, did I? But it's still going to compile unchanged. And I have a final variable pointing at a mutable object. That mutable object state can be changed. Why? Because final means cannot be reassigned. It does not mean cannot be changed. Const means cannot be changed. And constness only occurs when the variable's finite and the object's immutable. And I will recompile this in case there are any doubting Thomases out there. And you will see that it will happily compile. There you go. So that's the final keyword. Now, one convention you will observe in Java is this. If I go into JShell for a moment here, and I type math.pi, if something is const, a universally observed convention of Java programmers is that it be set, the identifier be set in all caps. Here's another example of a constant. Integer.max_value. Okay. Ooh, that's the maximum value of an integer. So, when things are const, they should be set in all caps. We'll do some little cases today and see this in action. Now, one place you might see it in action is in a class that you want to render immutable. Now, to that end, I think somewhere here I have a, do you mind? I have a point class. Let's see if this has everything I want in it. Oh, no, it doesn't have everything I want in it. Okay. Let's go ahead. You know what? I will construct this thing from scratch. Why not? Because maybe you haven't seen it before. We're going to make an immutable class of points that have integer coordinates. Okay, now what I'm going to do here is I have marked x and y, the two coordinates of this point. These are points with integer coordinates. I've marked them final. That means, and they are primitive, so they are constant. They cannot be changed. Now, a big reason, I'm not going to give them capital letters, and the reason is they're not going to be seen outside of this class. Okay? In general, if you have something at state, mark it private. Now, so let's go ahead and make our point class. Okay, that's easy enough. I'm going to initialize my x. I'm going to initialize my y. Done. All right, I'm going to make, and you've seen this before, hopefully. You can use the word this to call a sibling constructor inside of a constructor. All right. So, and now let's go ahead and put in a toString method. All right. And that's an easy matter. We'll just use our old friend string.format. %s, comma, %s. All right. There's our toString method. Okay, so here is our point class. And we have, first of all, even if I never declared these final, in this state, this class is immutable. Why? There is no access provided to the final variables x and y. But later when we do something with static, we may find it useful to protect these guys in another way. Because there's something we're going to do later on that could break that security. Now, while I'm in here, why don't I go ahead and make an equals method? Okay, this is easy enough to do. Object O. And so what I'm going to do here is, of course, if not O instance of point. So if it ain't a point, it fails the species test, we return a false. Okay, then what we do is we just say point that equals point O, and this cast is guaranteed to work. Why? Because if it weren't a point, we'd be out. All right. And y double equals that dot y. Okay, so we have this. All right, and maybe we'll add, I'm going to add one regular method, just so this looks like a class. Oh yeah, let's compute the distance to another point. And that's easy enough to do. We can use our old friend math.hypot. Of x minus that dot x, comma y minus that dot y. The distance formula you learned in high school, geometry. Okay, so here we have our fully featured class. And this class is a class of immutable point objects. And the reason I generate it is we're going to return to it when we start discussing static. Okay, so we have an immutable, we have a set of immutable point objects. They know how to represent themselves as a string, compare themselves to other objects, and compute their distance to another point. And we could chuck other methods in here. We could put getters in here if we want, but let's go ahead and leave this alone as is. All right. So finality can be used to enforce immutability. And a good rule of thumb is if you do not contemplate any need ever for changing a value a variable points at, go ahead and mark it final. Okay, so that's the final keyword. Now let's move on to our friend static, which is a little different. I'm going to bring up a browser window with a diagram in it, because I think this diagram is extremely useful. All right. A class is divided into two parts. I call them instance land and static land. And the static rule, etiquette rule applies. So it looks like this picture. In instance land go your state variables and your non-static methods. So if it's not marked static, it's part of instance land. To be static, you have to be marked static. So static methods, you can have methods that are static. You can have data, variables and constants and those kinds of things you can mark static as well. Things that are static are shared by the class as a whole. They're properties of the class as a whole. And as a result, this side of the wall between static land and instance land is greased because static things are not allowed to climb into instance world. But on the other hand, things that are that live in instance land do have access to static land. Okay, so there is a one-way access. It goes this way, but not this way. Now, when you first make an instance of a class, the class loader loads that class into memory. And the first thing it does is it creates a static area. The static area is like a billboard that's pinned up in memory, and all the instances of the class can see into the static area. Now, you can mark things in the static area, independent of whether they're static or not. You can mark things public or private or final. All those properties are independent of each other. So the static area gets put up first, and then you have all the instances of your class. So what we're going to do is we're going to give our point class a static constant. And we'll also violate the static etiquette rule so you can see it being enforced. I thought this class might be handy to have around. You bet. Now watch this. These two things are not marked static. They are part of instance land. The toString method is part of instance land. And a good tell for this, does that outcome of the method depend on the state of the class? If it does, it's in instance land for sure. Now, it's possible to have things that don't depend on the state of the class to be in instance land as well. That is possible. In fact, it frequently occurs. Now, here's a very common mistake of brand new bucko programmers. They come into their point class and they put a main method. Ooh. So a main method is a shared method of all instances of the class, and what it does is it makes the class executable. You can run it. Now, the thing I'm going to do inside of here, it's a no-no, is I'm going to go ahead and try to print X. Okay? This is part of static land. X is not part of static land. Watch the compiler get annoyed. Whoops. Non-static variable. So when things are non-static, that means they're part of instance land. Cannot be referenced from a static context. Okay? So you cannot do that. So, what can you do? Now, you can do this. Okay. And the reason for the static etiquette rule is every point you create has different instance variables. And so if I were to say X here, the question becomes, who's X? Right? So this absolutely makes no sense at all. However, you can do this. You can say point P is equal to, I just made a point here, right? And I can even do this. And I can print P.Y. and I'm going to print P itself because I have a toString method, and it will print nicely. And you're going to see, since I'm inside of the class here, I have access to these private variables. All right. Okay, so I'm going to JavaC that. Oops, I'm missing a return statement. Oh, I forgot to say return here. My bad. For some reason, it's picked up editing the file twice. I'll get rid of that. So let's recompile here. And look at that. Now, one thing I cannot do, because I'm protecting myself, is I cannot do this. Watch what happens when I try to do that. You won't get to execution. This is a compilation error. The compiler is enforcing finality. Okay, so violating finality is a compile time error. Okay, so now we've seen our violation of static etiquette. We're going to now create static data. And generally, I like to create that right at the top of the file. I'm going to say public. Ooh, I'm going to make something public. Okay, so this is visible outside the class. It's a property of the class as a whole. It's final. Now, my points are immutable. So I'm going to use capital letters. Now, if you make static things like this, you can initialize them in the static block. Oh, come on. I hate that cap locks key. All right, so origin is new point, and that's going to be my origin. And since points are immutable, that's const, so I'm using capital letters. Okay, so this can be seen outside the class and inside or outside of the class. Inside the class, you can do this. All right, you can say, all right, you can do that. You can do that anywhere inside of the class. Origin is accessible inside the class to instance land and to static land. I can do that. I'm allowed to do that. However, this is better, and this is what you can do outside the class. Okay, point dot origin. So the point dot says, oh, this is a class name, so that must be static data. Capital letters say this is a constant. And let's go ahead and compile and run. Oh, and let's get rid of this. Ooh, oh no. That violates the finality of X, so I shall get rid of that. And now let's go ahead and let's compile it. Whoops. Oh, you know what I forgot in here? It's so easy to forget things. There's so many bloody keywords. I need to specify the point. Type. All right, let's try that again. Yes. See, so there's the origin printed twice. All right. So this is the creation of a static piece of data. Okay. And so what happens when you make a new point? Before anything happens, the first time the class is encountered, the class loader loads this static area into that bulletin board that all members, all instances of the class can see. So it's there, and we even marked it public so other classes can see it, right? And then it goes ahead and constructs your object or objects. So once the class is loaded, you can spit out instances of your object. Now, you might think this is a relatively trivial thing, but I'm going to show you a non-trivial use case for both static and final working together. So I'm going to make a new Java program. It's going to be called minter.java. Okay. There it is, minter. Okay, and I am going to need the constructor. And I'm going to do some things that seem a little bit on the crazy side. First of all, I'm going to say private static int id well semicolon. And inside of here, what I'm going to do is I'm going to say id well is equal to 0. So I've created this static piece of data. Now, the next thing I'm going to do is I'm going to give my minter state. Private final int id semicolon. I could even make this thing public because I can't change it, but I'll keep it private anyway. All right. So here's what I'm going to do. Two things. I'm going to add one to the ID well. And I'm going to assign that value to the ID of this object. So every time I create an object, the ID well value increases by 1. What are we doing here? We're giving serial numbers to our objects. Okay, so to see things, let's go ahead and make ourselves a nice little toString method. Okay, public string toString. And I'm going to do about the most simple-minded thing possible. Okay. I'm just going to return the name minter and then inside the parentheses, the ID possessed by that minter object. Okay. So this is what we have so far. And you'll notice the ID is final, so it can't be changed. Okay. So this object, the minter object, is actually an immutable object. So now let's go ahead and make some. So I'll get out my favorite for loop. 10k++. So I'm going to make a new minter. All right, and I'm just going to print it out. I'm not even going to bother to name it. That's it. So there's my main method. Okay, and now let's see how this all works. Okay, I'm going to go ahead and compile it. Ooh, creepy. No compiler errors. Hey, look at that. So it issues successive serial numbers to the objects that I spawn. So there's a nice use case for static. It's very interesting. What is static is the ID well. All right, that's what's static. The ID well is static, but the ID itself is not. So what's happening here is something, I am going over the wall, but I'm going in the permissible direction. I'm going in the direction from static to instance, which is allowed. Okay, so now we can see a very nice use of static and final together. Now, one thing I haven't done is I haven't created a static method. Now, you've seen static methods. The math class, how do we compute the cosine of something? We use math.cosine. And when you see the class name dot a method, that's a tell. Tells you it's a static method. So math.cosine, math.sine, everything in math is static. And in fact, what they did in math is they took the constructor and made it private. So you can never make a math object. Okay, you can just use the methods that are inside of it. That's the nature of what is called a static service class. Okay, so we now have our Minter class. We're now going to make a new class. We're going to make a class called Triangle. Oh, let me bail out of here. I'm going to go ahead and make it this way. Okay, I'm going to need to put in the date. 10/23/2020. Okay. Oh, crud. Let me do that again. Let's get rid of .java. Because that would just be awful. All right. So, triangle. Now, here's something I learned in Mr. Rayshap's geometry class way back many centuries ago in 10th grade. And that was, you can specify a triangle by 3 sides. Okay, we're going to do that here. Because we're only going to be interested in computing the area, diameter, and perimeter of a triangle. Okay, so I'm going to make side 1. Here I'm going to make side 2. And I should mark them all private, I suppose. Yes, it's a good practice to mark all state private. All right. So we're just going to plow ahead, and we're going to say this dot side 1 equals side 1. Okay. There we go. All right. So I've gone ahead and done that. Now, you, being the keen observer that you are, probably see some kind of trouble brewing on the horizon. However, we're just going to proceed blithely along, and we will eventually address that trouble. So here's my area method. All right. And I'm going to copy this. And here's my diameter method. And then down here is my perimeter method. And my perimeter method is like fish in a barrel. Let's go ahead and do that. All right, beautiful. All right. Hey, the perimeter is easy. Now, the diameter of a shape, all that means is what is the distance between the two most distant points? Well, if you think about a triangle for a second, the two most distant points are the vertices on the longest side, and their distance is the length of the longest side. So we're going to get out of friend math, and he has the good old Grinch dog here. I'm going to max side 1. And it's just the maximum of the 3 sides. Okay, so everything looks pretty copacetic so far. Hey, I'm going to go ahead and compile this. Make sure I'm not missing any semicolons. Oh, I'm missing return statements. I'm missing a return statement here. Let me just stub this in. Because we got a little work to make that happen. Where else am I missing a return statement? Area? Oh. Duh. Okay. Yeah, let's whip that into shape. Okay, it now compiles. But there is an ugly problem. The ugly problem is this. How do we compute the area of a triangle from its three sides? This sounds like a problem that's for the birds. Well, actually, it is for the birds. The bird I'm thinking of is the heron. Okay, that's the heron. And there is something called Herons Formula out there. And I'm going to bring it in here and show it to you. You can Google for this. It's very simple to find it. All right. And you will see what you do is here's your triangle side, side, side. Mr. Rayshap said that term is a triangle, so we should be able to compute its area. So what you do is you compute something called the semi-perimeter. That's half the perimeter. All right. And then you have a square root here. Now, let's think about square roots for a second. We know that the square root's domain is non-negative numbers. So were this down here to be negative, we'd have a problem. Now, you should be aware of something called the triangle inequality. The triangle inequality says that for any given side of a triangle, that side's length is shorter than the sum of the two other sides. Let's go back there. Come on. Right? That's called the triangle. And, to really check this out, you'd have to do 3 if statements. No. Here is a dirty, rotten, stinking, filthy, oleaginous trick. If this radicand is a non-negative number, you have a legitimate triangle. Now, if it's 0, it's degenerate because it's like a 3, 4, 7 triangle, and that's like completely flat. It has an area 0, but that's fine. I can live with degeneracy with triangles. But if it's negative, you have an invalid combination. In fact, an 8, 1, 1 triangle, you can't construct. And if you plug 8, 1, and 1 in here, you should see what you get. You get a negative number. So, we do not want that moron who is using our brilliant code to introduce an illegal triangle onto the scene. Degenerate is okay, but we all draw the line at illegal here. So here's what we're going to do. We're going to make a private static method right here. Let's put it. Okay, and you'll notice I can't access side 1, side 2, or side 3 directly here. So what I'm going to do is I'm going to say radicand, because that's the thing you put under a square root. It's called a radicand. All right. And I'm just going to do that. Okay. So I'm going to compute the semi-perimeter just like the directions say to do. A plus B plus C divided by 2. Now I'm going to return S times S minus A. This is Herons Formula. Times S minus B times S minus C bingo. Now, wouldn't it be lovely if we could take a cream pie and stuff it into the face of the idiot client programmer who tries to construct an illegal triangle? And this is how we do it. We just say if. Now, we're in instance land, so we have access to things that are static. So we can use the static method radicand, and we can pass in these 3 numbers, side 1, side 2. They're just 3 numbers, right? 3. I'm missing a parenthesis. That's why the editor went wacky on me. Okay. No, I don't want that. Let's just delete that line. Let's try that again. All right. So I'm going to throw a new illegal argument exception. This is a type of exception. What is an exception? An exception is a bullet, a speeding bullet headed straight for the beating heart of your program. And if it gets thrown at your program dies right at the spot. Now, this is not a compiler error. This is a runtime error. So this will abort the execution of a program done by a client. Now, usually, in this case, the person using the triangle is probably another programmer. He's not a paying customer. Paying customers, you don't want to dish out death to them. But other programmers, yeah, if they screw up, they deserve death. So let's go ahead and do that. And now I can do this. Area. All I have to do here is say return math.squirt of radican of side 1 to side 3. Okay, that produces my, let's see. Yeah, that seems to produce what I want. Now it's time to check it out. Now I'm going to use a test case for which we can easily compute the answer of 3, 4, 5. And you notice I marked that method private because it really there's no need to see it or to clutter up your triangle's sleek interface. Area, diameter, perimeter, very nice. Now let's go system that out. Okay, so before we even start, we're going to do this. We know what the area is supposed to be. Let's compute it. You should recognize that this is a 3, 4, 5 right triangle. 3 and 4 are the base and the height. 3 times 4 divided by 2, 6. We better get a 6 here. The longest side is 5. We better get a 5 there. The perimeter is 3 plus 4 plus 5 is 12. So 6, 5, 12. Oop. Uh-oh. I have a missing, I have an extra curly brace. My bad. Wait a minute. Given types. Whoa. Oh, you know what we forgot to do here? We forgot to do this. Ooh, it didn't catch that until that was a runtime error. Let's recompile. And what's the problem here? Oh, we have something going on with S. Maybe I didn't say double S. Did I fail this? Oh, I did. I must specify the type of the variable. Okay, double cannot be converted to Boolean. Oh, because I said less, I need to say less than 0. Oh, sloppiness is catching up. But, you know, this is normal stuff when you compile and run live. You're going to see things like this. This is what your experience is going to be like. Okay, now, let's do this. We're gonna try to introduce our famous 8-1-1 triangle onto the scene. Die now. Okay, by this juncture, your program should be dead. So you should not see this last statement execute. Let's see if that in fact happens. Oh, illegal argument exception. Do you see that your program died right in its tracks? Yes. So this statement, I made an illegal triangle, caused immediate death of my program. So now you know about final, one of its context, and that's final variables. Final variables cannot be reassigned. Static. Your class effectively is divided into two parts, instance land and static land. And things you mark static live in static land. Things you don't mark static live in instance land. Things that are static may not access directly non-static portions of the class. You have to create an instance of the class, and then you can gain access to things, but you can't gain access to them directly. On the other hand, we saw that right here, that things in instance land can access, here's the best example of that. The area, that's part of instance land, and it's accessing something that's static. So there's your etiquette. Your etiquette is static land, has no direct access to instance land, but the other way around, instance land has access to static land. And that's the two keywords, final and static.